Okay, in this problem, the relationship between the number of pencil sharpeners x, so x is the number of pencil sharpeners, and that a company can sell each week, and the price of each pencil sharpener, lowercase p, is given by this equation. Okay, we're not worried about how they got that, obviously. So x is the number of pencil sharpeners, and then p is the price, right there. Okay, is given by this equation. So at what price should the sharpeners be sold if the weekly revenue is to be $6,000? Now, there's a little bit more to this problem than maybe first meets the eye, because there's nothing about revenue in this equation right there. Now, if you look in your book on page 29, there is an explanation and then an example involving revenue, price, and number of items sold. And I definitely recommend that you read through that problem and look at that example. So actually, I'm going to pull that up and look at that one instead, and then we'll come back to this one. Okay, so this is it right here. So this is just an explanation of profit, revenue, and cost. So profit is the revenue that you bring in minus the cost that you spend. But this part down here, okay, revenue is the number of items sold times the price of each item, right? So if you sell 100 t-shirts at $5 each, you multiply the 100 times 5, and your revenue is $500. So in this example, if x, and this is the same variables in the problem that we're looking at, if x is the number of items sold and p is the price of each item, then revenue is their product of x times p. So coming back over here, let's write that out. So revenue is equal to the number of items sold times the price that they're sold at. So if the weekly revenue, we want that to be $6,000, we'll replace R by 6,000. Now we have two variables here, x and p, so difficult to solve for. However, x is equal to this in terms of p, so we can replace that x by that. I think you see where this is going. So 1,700 minus 100p, all times p. Now I think most of you should be able to get this from here, but I'm going to keep going because just in case you're lost on how to solve this. It's not obvious at first glance, but this is actually a quadratic equation, because when you distribute out this p right here, you're going to end up right there with a p squared. You're going to have a p squared term, a p term, and a constant term. So we're going to need to solve this quadratic by getting it equal to 0 on one side. If this is a nice problem, it will be factorable. If not, we might have to use the quadratic formula. So let's see, distributing p would give us 1,700p minus 100p squared. I don't like having negatives in front of my p squared term, so I'm actually going to move both of these two terms over to the left side so that they become positive. So I'm going to add 100p squared to both sides and subtract 1,700p from both sides. And then this is this 6,000 right here, positive 6,000 equals 0. What I would probably do is, you notice, everything has two zeros. So you could divide both whole sides, everything here, by 100, just basically to knock off two zeros of everything, just to make the numbers a little bit smaller. So then you would have p squared minus 17p plus 60 equals 0. And let's see, that might factor. 60 could break down into 12 and 5. 12 and 5 could get us 17. So I think you can probably solve it from here. It is factorable, which is nice. And that'll give you the two values of p at which these pencil sharpeners could be sold at. If you have trouble with this, just let me know and I'll help you further.